Hello everybody and welcome to my talk. My name is Frank Schäfer and I'm a third-year PhD candidate in physics at the University of Basel. Together with Frank and Moritz, we implemented the backward filtering forward guiding algorithm in our new package MitosisStochasticDiffEq. The backward filtering forward guiding algorithm is an algorithm that allows for sampling conditioned Markov processes. In this short talk, I will show to you how we can actually use that to infer the parameters of stochastic differential equations. Let's take a concrete example for that. So we will take as an example an SDE on a tree. So suppose that on each branch of the tree, the forward model looks as follows. So we have here x dot t is the state of the differential equation, which consists of two components, x1 and x2. And in addition to that, we have four parameters, theta1, theta2, sigma1, and sigma2. The forward simulation of the model can then be visualized as follows, where we have the first component here and the second component both as a function of time. In all what follows, we assume that we know the precise branching times of the tree. As the observations, we then take the leaf variables of the tree. So we have here these black dots are our observations. The task is then to infer the parameters based on these observations. This is actually a non-trivial task because Kalman filtering can't be used directly because we have here this nonlinearity in the drift function. In what follows, I want to explain to you how to use the backward filtering forward guiding method to infer these parameters. The first step is to filter the information backward given the observations and an auxiliary process. So this auxiliary process is just some approximate dynamics which we choose as a linear SDE. The package then implements these backward filtering functions which compute a message for you. So these messages are then visualized here, and these give the expected trajectories to which we want to guide forward simulations. So the second step is then to guide SDE trajectories which are conditioned on the parameters forward such that they follow approximately these messages. The main trick here is that we can compute a weight that accounts for using these approximate dynamics in the backward filtering. Given the guided forward trajectories and the weight, it's actually then straightforward to set up parameter inference. So we can use Metropolis-Hastings or variational inference to infer the parameters of the model. So we have here these trace plots for a Metropolis-Hastings algorithm as a function of the iterations, and we see that they nicely fit the true parameters of the model. I just want to mention here also that we implemented different parameterizations for the backward filtering, and we also implemented different functions for specific SDE forms. With this, I'm already at the end of my talk. I want to thank you for your attention, and I'm looking forward to your questions.